Alrighty. Okay, diffraction grating. So what do we know? We know the wavelength is 428. We know that the beam is, we're not going to use this yet. We'll use that in the second part of the problem. We know that theta is 3.58 degrees. So we better have our calculator in degrees, right? And then we want, they're giving us the angle for the second order. So n equals 2, right? So to do this, we're going to use d sine theta equals n lambda, right? So let's see, lines. Okay, so what our strategy here is, let's figure out what d is, the distance between the lines, and then we can figure out how many of those fit into a centimeter, okay? So let's solve for d, and then we can figure out the lines per centimeter. But let's do this first. Okay, so our d is going to be n lambda over sine theta. That's 2 times 428 divided by the sine of, and again, better make sure you're in degrees, right? All right, let's do this. 2 times 428 e minus 9 divided by the sine of 3.58. And I'm getting that d is equal to 1.370869 e minus 5, which isn't fantastically small, but it's small, okay? So we've got that. Now let's see, how many of those fit, this is meters, right? So how many of those fit in a centimeter, right? Well, a centimeter is 0.01 meters. And if we divide it by this, and this is meters per line. This is meters per centimeter, right? Okay, we're going to end up with lines per centimeter here, right? Okay, so that number to the minus 1 times 0.01, that's 729.46, right? Ta-da! All right. So now let's go to the next question.